We're on to the last of the short questions. And this was going to be one that some students will love it. They'll have practiced plenty of constructions. They'll know what the orthocenter is, the circumcenter, and the centroid. They may never have seen a question quite like it, but hopefully they will be able to complete it successfully. So the Euler line of a triangle is a line going through three important triangle centers: the orthocenter, the circumcenter, and the centroid. Construct the orthocenter, circumcenter, and centroid of the following and join these centers together to form the Euler line, or some people call it the Euler line. So we begin with this construction. Again, people mightn't be familiar, of course, with the Euler line, but you just start off. You know, you create your centers and you see where you go from there. Of course, with any of these, you must show your construction lines. You don't rub them out at the end. So here at the start, it's what we're doing here is we're talking about an acute triangle. All angles are less than 90. So the orthocenter is relatively straightforward to create. We just slide our ruler along and make sure when we're drawing our altitude that it's going through, in this case, the top vertex, and it's hitting the opposite line at 90 degrees. So we can see our right angle here. So I choose a second of the vertices, the one at the bottom left, and again, I'm going to hit the other line, the line opposite at 90 degrees, and that is my second altitude, and I have created my orthocenter. So I could do this third altitude, and that would also go through that same point. So now I am going to, what's happening next is I am bisecting two of the lines, okay, to the sides. So on the left-hand side, I create my perpendicular bisector. Then using the line on the right-hand side, I create my perpendicular bisector again. Where those two perpendicular bisectors intersect each other, we have the circumcenter. And using the perpendicular bisectors, that helps us then to find the centroid, because we can go from the point where the perpendicular bisector cuts through the side, and we go from there and we go across to the vertex opposite, and we create a median line. So we have our first one, and we create our second one. As I said, they're relatively easy to do once you've already got the perpendicular bisectors in there. And now we have our centroid. So we have our three centers, as we can see on our diagram here. We can see that they line up, and the 3 points are collinear. We draw our line and we have our Euler line. So it looks very easy when you're doing it here with the computer graphics. However, not that many students actually get the 3 points to be collinear. So you have to be very accurate. Okay, so 20 marks for that. Our last part is a bit of area volume, bit of geometry knowledge. It says in the given figure, the square ABCD has side lengths of 3 units. Find the area of the shaded region between the circle and the square correct to 3 significant figures. Okay, so what are we going to do? Well, it tells us the side length is 3 units. Okay, so I'm just looking, it's not saying centimeters or anything like that, but we can use that information to help us find the diameter of the circle, which is AC. So using Pythagoras' theorem, we can say the hypotenuse, which is AC. AC squared is equal to 3 squared plus 3 squared. It's equal to 18. So therefore, AC is the square root of 18, which is 3 root 2. That is my diameter. Of course, I can then say my radius is half of that. So it's 3 root 2 over 2. And I can do that. I can use that information then to find the area of the circle, pi r squared. So the area is going to be pi times 3 root 2 over 2 squared. The area of the square is obviously going to be 9. 3 times 3 is 9. You take one area from the other, so the 9 from the area of the circle. I'm going to get my answer. And I have to just make sure I look back at my question. It is correct in 3 significant figures. So my 5 is significant, my 1 is, my 3 is, my 7 is. They're all significant figures. So what am I going to do? I'm going to look at my 4th significant figure, which is my 7. Because that's 5 or greater, I'm going to be rounding up. So the 3 will get rounded up to the 4. And it's units squared. And as often can be the case, some students will make a little error in the rounding to 3 significant figures, and some people could make an error in the unit. And, at the end of the question, you don't want to give the marks away. After doing all the hard work, if you have it all done correctly, you want to make sure you get 30 out of 30 at the end. So that is the end of the short questions. And now we move on to the longer context and applications questions.